In previous videos, we have seen how much energy we use and how it can be measured. But now the critical point is how much emissions does that energy use generate. In this video we will explain how CO2 emissions can be calculated. We will focus on the emissions associated with conventional fossil fuels, because, as we have already seen, fossil fuels are the most important source of CO2 emissions. To calculate the emissions, we first must grab the concept of an emission factor. An emission factor tells us the amount of emissions produced from the combustion of one unit of energy. It is expressed, for example, in kilograms of CO2 per gigajoule of energy. We have already seen that various energy carriers have different energy contents, and also various energy carriers have different emission factors. The emission factor for natural gas is lowest, at only 56 kg of CO2 per gigajoule. You see, oil has a somewhat higher carbon intensity, with a typical value somewhere around 70 kg per gigajoule. There is a variety of oil products and their emission factors differ a bit. Finally, we have coal, which is the most carbon intensive, with a typical emission factor of about 95. This is valid for hard coal. All these values vary somewhat depending on many factors. The higher emission factor for oil and coal is largely due to their higher carbon to hydrogen ratio compared to natural gas, which is mainly CH4. More details about these emission factors will be given in the additional material for this week. Let me now give an example of how these emission factors can be used. Assume you drive a car and it uses 1,500 liters of gasoline per year. We have seen in an earlier video that 1 liter of gasoline is equivalent to 33 megajoules. So in a year your car will use 49.5 gigajoules. Now we need the emission factor for gasoline, which is 73 kilograms per gigajoule. We then multiply the energy value with the emission factor for gasoline. We see that driving your car for 1 year will produce 3,614 kilograms of CO2, a bit more than 3.5 tons. So this is the basic approach for calculating emissions. You can use the same formula for all different fuels and energy uses. So far, we've talked about what we call direct emissions, the emissions that leave your chimney or the tailpipe of your car. These can easily be calculated based on the amount of energy that you use. But virtually everything you do leads to greenhouse gas emissions. Whether you use electricity or you buy a coffee or a new table, every activity always has a quantity of associated emissions. These are called indirect emissions. Calculating these emissions can be a lot less obvious. This distinction between direct and indirect emissions is formalized by distinguishing so-called scopes. So firstly, in scope 1 we have the direct emissions, those that leave your chimney or tailpipe or otherwise generated at your premises. Scope 2 and 3 both relate to indirect emissions. Scope 2 is a very specific category. These are all the emissions that are associated with the electricity that you purchase. The emissions generated in a power plant that produce electricity for you are your Scope 2 emissions. Scope 2 also includes emissions associated with other energy carriers that you are purchasing, for example heat. But in general, electricity is most important. Scope 3 encompasses everything else that you do that causes emissions. It can be upstream emissions, emissions to create products that you use, or downstream emissions, emissions that will be generated from creating a product. For example, for a car manufacturer, the emissions for making the steel and plastics for the cars are counted as their Scope 3 emissions. But also the tailpipe emissions from using the car are part of their Scope 3 emissions. What is also clear from this example is that certain emissions will be classified under a certain scope for one person, but in a separate scope for another person, depending on their position in the energy system. For instance, if a power company generates electricity with coal, the emissions are scope 1 emissions for them. But for you as an energy consumer, they will be scope 2 emissions. We will now dive a bit deeper into calculating scope 2 emissions. If we use 1 kilowatt-hour of electricity, what is the emissions that we are causing? Let's first look at a simple case in which all of the electricity is produced by natural gas fired from power plants, with a conversion efficiency of 50%. The emission factor of natural gas is 56 kg per gigajoule. As 1 megawatt-hour is 3.6 gigajoule, we need to multiply with 3.6 to get the emissions per megawatt-hour of natural gas. We get about 200 kg per megawatt-hour. When we also take into account the conversion efficiency of the power plants, we need 2 megawatt-hour of natural gas for 1 megawatt-hour of electricity. The outcome is about 400 kilograms per megawatt-hour or 400 grams per kilowatt-hour. The latter one, grams per kilowatt-hour, has become the most common way to express emissions of power generation. In reality, a country will produce electricity from a variety of sources, both renewable and non-renewable sources, and with more or less carbon-intensive fuels. The indirect emissions produced from a unit of electricity will depend on the composition of electricity production units in a certain country or a region. The CO2 emission factor for electricity may be as high as 1000 grams per kilowatt-hour in countries with coal-intensive power generation and below 100 grams per kilowatt-hour in countries relying heavily on nuclear power, hydropower, or other renewables. The global average emission factor for power generation is about 450 grams of CO2 per kilowatt-hour. Finally, we now look at the calculation of scope 3 emissions. This is much more complex because what you basically need to do for a given product or service is to follow the complete life cycle of the product and find the associated emissions at each stage. For example, in the case of steel production, you need not only take into account the emissions that are generated when steel is forged, but we also need to look further upstream, the emissions from the winning of the ore, iron ore and coal, the emissions generated during transport of the ore and coal, the emissions from coke production, etc. You can see this is already quite complex for a relatively simple product like steel. For other products, for example a coffee machine, which consists of many different components, this analysis is even more complex. The sum total of these emissions are the scope 3 emissions related to the product. The shorthand is the carbon footprint of that product.